Kia ora koutou katoa, welcome back to another video. Today we are going to be looking at integration by parts, which is used in physics and calculus. It's used in physics when you're solving equations using calculus, so it's used in calculus and in terms of integration. So we are going to look at rearranging the product rule for this equation, and let's just start off with knowing that the product rule d dx of f of x g of x is f prime of x g of x plus g prime of x f of x. We are assuming that you have a knowledge of the standard differentiation rules and standard integration rules here. So we can actually rearrange. How can we rearrange? Well, we just want to rearrange for one of these equations on the right hand side. So let's rearrange for the first one. Let's call it 1. So we subtract g prime of x, f of x from both sides, so we get f prime of x, g of x is equal to d dx f of x, g of x, subtract g prime of x, f of x. And now let's go ahead and let's integrate on both sides. And this gives f prime of x, g of x, the integral of that product, is equal to f of x, g of x, minus the integral of g prime of x, f of x. So basically, integration by parts is just a rearrangement of the product rule, and then you just integrate. That's all it is. And sometimes you might see it in the form of, I think it's uv prime is equal to uv minus the integral of vu prime. You can see it in this form as well. It's the same thing. So that's how we can deduce the formula for integration by parts. So you don't actually have to take this step when using integration by parts. This is just finding the equation. So let's go ahead and do an example. So yes, let's use integration by parts to solve this. Now you could just use the power rule, but let's go ahead and not use the power rule. But in a way, we are going to use the power rule, and you'll see why. Well, let's write this as the integral of x dot x dx. So we have the form here, f prime of x multiplied by g of x. So if we allow x to be f prime, well, that's the only choice we have, then f of x is going to be x squared over 2, and then we multiply by g of x, which is x, and then we subtract by the integral of g prime, which is just 1, and then f of x, which is x squared over 2 dx. So we get x cubed over 2, take away the integral of x squared over 2 dx. And we already know what the result should be. It should be something like x cubed over 3 plus c. The problem here is, are we going to get that? Well, let's see if we do get that. So x squared over 2 stays the same. We get x cubed over 6. So that's actually x cubed here. X cubed over 2 minus x cubed over 6. And we also have to add the constant of integration, because we're not dealing with a definite integral, we're dealing with an indefinite integral. So it has a family of curves. And now we can make the denominators the same by subtracting, we can multiply this by 3, and that becomes 6. And we get x cubed over 6. And that makes us get x cubed, 3x cubed minus x cubed over 6. And that is 2x cubed. I did it again. put a squared, that is a cubed, 2x cubed over 6, and that gives us x cubed over 3, and we also have to add our constant of integration, and we know that that is true by the power rule. So we have proven the integral of x squared dx is indeed x cubed over 3 plus c by the integration by parts law. But we know rules for that. We don't actually have to specifically use integration by parts to solve those equations or those integrals. But we have to use, or we can use, or it's the best way to use, solve something like this: x cos x dx. In this case, we don't know how to integrate the product of this without integration by parts. We could expand the cosine function into a Taylor polynomial and get a solution that way, and maybe be able to do some factorizations to get a product of two Taylor polynomials, and then you can realize, okay, that's the Taylor polynomial for that, and that's the Taylor polynomial for that, so that is that. So essentially trying to work out what the Taylor polynomials are showing, but we're going to use integration by parts. Here we are going to let g of x equal x, and cosine of x equal f prime of x. And what that gives is that will give us sine of x, take away the integral, g prime is 1, and the integral of cosine is sine of x, so we just put sine of x. And now we know how to solve this. We just get sine of x, subtract the integral of sine of x is minus cosine of x, so we actually get a plus. So we get plus cosine of x, and of course a constant of integration. And all you have to do is differentiate. So if I differentiate this, using the product rule for the first term, we get cosine of x, plus sine of x minus sine of x, because the derivative of cosine of x is minus sine of x. These two cancel, you get what you originally had back. So this is indeed the integral of x cosine of x. So it's pretty useful. Sometimes you'll have to use integration by parts more than one time, and I will focus on that in the next video to be uploaded. But integration by parts, in my opinion, is a very nice technique of integration.